Hey everybody, Mr. Reeves here with you once again. And today we're going to be talking about cubes and cube roots, but we're going to be connecting it to squares and square roots. So a lot of this might be what you're already familiar with, but helping us to going back over squares and square roots will help us to understand cubes and cube roots. At least I hope it will. All right, so over here on the left-hand side of the screen, I have this table that I think I showed you before. It has the numbers down the first column, and then it has the squares of those numbers in the second column, and then it has the cubes of the numbers in the third column. So if we take a look at what we have here, all right, 1 squared is 1 because 1 times 1 is 1. 1 cubed is also 1 because 1 times 1 times 1. So this one is 1 times 1, right? This one is 1 times 1 times 1. All right, 2 squared is 4 because it's 2 times 2. And 2 cubed is 8 because it's 2 times 2 times 2. I think you have the idea here, right? Oops, didn't mean to do that. We'll just let that get out of the way. I didn't mean to open up the calculator. That might come in handy later, though. We'll see. All right, so if we go down here to 5, 5 squared is 25 because 5 times 5 is 25. And 5 cubed is 125 because it's 5 times 5 times 5. Now, why the name square and why the name cube? Well, that's why I have this diagram over here. All right, so as you can see, these numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, those are the numbers that are right here in this square column, right? Can you see that? I don't know why it's freaking out on me like that. All right, 1, 4, 9, 16, 25, 36. There's those numbers right there, right? Let me see if I can go. All right, that has them pretty good, right? So there's those numbers right there in the squares, and then there's those numbers right there in the cubes. Well, why are those numbers there? Well, when you have a square and you find the area, it's length times width, right? This square is 1 times 1, which is 1. This square is 2 times 2, which is 4. This square is 3 times 3, which is 9, and so on, right? So when you square a number, you are finding the area of the square with that side, right? So if I said, what's the area of a square with sides 9, it would be 81. What's the area of a square where each side is 7? 49. What's the area of a square where each side is 36? It's 6, right? And if I give you a square number, so let's go down here. Like if I said I have a square that has an area of 625, that's a beautiful square. Isn't that a beautiful square? If I have a square that has an area of 625, then each side would be 25, right? Because 25 times 25 is 625. If I have a square that has an area of 484, then each side would be 22. So they are called square numbers because they give you the area of the square. All right? They give you the area of the square with this as its side. All right, so if I said, what is the area of a square with the side of 32, the answer would be 1,024. If I said, what's the area of a square with the side of 39, the answer would be 1,521. Okay, see how that works for squares? Well, and it works very similarly for cubes, except now instead of finding area, we're finding volume. All right, so I'm going to write area right here for squares. And right up here for cubes, I'm going to write volume. Okay, so now we're finding the volume. All right, instead of just a 1 by 1 square, we have a 1 by 1 by 1 cube, right? Instead of a 2 by 2 square, we have a 2 by 2 by 2 cube. You get the idea? This is a 3 by 3 square. This is a 3 by 3 by 3 cube. So squares are two-dimensional, cubes are three-dimensional. All right, a square number is the area of a square with that as its side. A cubic number is the volume of a cube. And by the way, we call these edges when we get to 3 dimensions. It's kind of weird. What was a side becomes an edge. All right, and then this part here we call a face. So if I said, what is the length of one of these sides of that has a volume of 729? I could go over here to my cube, and I could go 729. Oh, 729, that is 9 by 9 by 9. Of course, we knew that because they match by color. Did you see how they did that? Isn't that clever? All right, so that's a 9 by 9 by 9, right? This 64 is 8 by 8. This is 8 by 8 by 8. So square numbers, again, give you the area of a square, where that number is the side of the square. Cubic numbers give you the volume of the cube, where that number is the edge. All right, and remember, square rooting goes backwards, right? Square rooting is when you start with the area and you ask for the side. Cube rooting is when you start with the volume and you ask for an edge. All right? Now, again, I have mentioned it would be good for you to memorize as many of these as you possibly can. All right? If you don't have them memorized, then you can use a calculator. All of these numbers here are called perfect squares or square numbers. All of these numbers here are called perfect cubes or cubic numbers. All right? So again, if I ask you to take the square root of a number, so for example, if I asked what is the square root of 36, remember we have a positive square root, that would be 6. We could have a negative square root, which would be negative 6, or we can have the positive and the negative square root of 36, which would be positive or negative 6. Now, what about if I did the cube root? If I ask you the cube root of 216, all right? Well, there's definitely 6, right? 6 times 6 times 6 is 216. There it is right there, right? 6 by 6 by 6. Now, is there also, by the way, oops, I forgot. Cube root has a little 3 here. That is so important. Cube root has a little 3. Square root could have a little 2, but we don't put the 2 there. But if we did, that would be a 2 there. That's a square root. Cube root has a 3. Now, with square root, we knew that 6 squared was 36, and negative 6 squared was positive 36 as well. So it's 2 different roots gave us the same result. Does that happen with cubes? 6 to the third power is 6 times 6 times 6, which is positive 216, right? What if I do negative 6 to the third power? What happens? I get negative 6 times negative 6 times negative 6, which is what? Negative 216. So while every square root, except for 0, of course, has 2 square roots, it has a positive or a primary square root or the principal square root, and then the negative one. You can always have those 2. With a cube root, if it's a positive number you're taking the root of, you get a positive answer. When would I get that negative? If I had negative 216. If I had the cube root of negative 216, that would be negative 6. Okay, so that is a big difference between taking cube roots and taking square roots. All right, I mean, I could still do this if I want to. If I put that there, the answer is going to be negative 6, right? But it's not an automatic like it is with the square root. Every time you square root a number, you're going to have the positive and the negative root. With a cube root, again, the cube root of a positive number is positive, and the cube root of a negative number is negative. Okay? The cube root of a positive number is positive. The cube root of a negative number is negative. But the square root of a positive number can be positive or it can be negative. Does that make sense? All right, so I hope this helps you out. I'm going to be making a different video on where we talk about approximating cube roots. So all I dealt with here was exact cube roots. Again, this table will be posted in Google Classroom. I'll probably post a picture of this as well to help you out. All right, have a great day, everybody. Until next time, bye.